Hello, everyone. Welcome to Computer Network series. So far, we have learned basics about IPv4 addressing and then IPv6 addressing and MAC addresses, how our laptop or any device, first time whenever it is connecting to the laptop, to the router, then how does it get IP address. So we have learned a few basic fundamentals about these things. So today we will be just covering a few questions and answers in relation to what we had covered previously for IPv4 address part. Okay, so I have shared my screen and we will be going through it now. So there are 14 questions which we have provided in the description of this uh, part as well. So you can have a look at those questions and think about those, and maybe it will give you an opportunity to uh, recall back what we have learned so far. So with not adding further delay, so let's get started. So let me just. So what does IP stand for? So it's Internet Protocol, which is a set of rules that governs how the data is sent and received across all networks worldwide. So whenever someone is talking about IP, so it stands for Internet Protocol. So looking at these two keywords, Internet Protocol, somebody can think of this is basically a set of rules. So protocol is basically a set of rules. And in this specific scenario, uh, these set of rules define how the data should be sent and received over the network for communication. So in short, IP stands for Internet Protocol. What is an IP address? So IP address is a unique identifier of the device on the network, right? So similar to the home address we have, wherein like uh, posts can be delivered to this home address. Likewise, uh, network, when we talk about the computer networks, so computer network is basically a set of machines, devices, or laptops connected uh, via some network device or in itself based on the topology. But then every device on the network has to have a unique identifier or the address. So that is what the IP address stands for, right? Moving on to the next one. What is IPv4? So as we had seen previously, so IP stands for Internet Protocol, and then V4 is version 4. So this is the initial or original version of IP addressing created in 1981. And then this IPv4 address is 32 bits to identify every device on a network. How many octets does an IPv4 address can have? So basically, if we look at this example IPv4 address, so it is 192.168 uh, dot 1.10, right? So here each uh, box or each number is an octet. So octet 1, octet 2, octet 3, octet 4. So in the IPv4 address, there are 4 octets, and each octet is 8 bits long, right? So an IPv4 address has 4 octets separated by dots. Each octet is 8 bits. And this is a sample example of 192.168.1.10. What is an octet? So octet is basically, as we had seen previously, so here each in this sample address of 192.168.1.10, every number or every box is an octet, right? So now this octet is nothing but 8 bits, right? So I mean, at each position in this octet, for all the 8 bits, we can have either 1 or 0. So in this example, we see it's 10100 100. So total we have 8 bits, and this is called one octet. It ranges from 0 to 255 because at each position or for each bit, if we put all zeros, then it will be a minimum value of 0. And if we put 1 at each bit position, then it will be uh, 255 in the decimal number system. So that's about what an octet is. Min and max values of a single octet. So as we have just seen, so for each octet, it's 8 bits, right? And 8 bits, the minimum value is in terms of binary, it's 00000000. Overall, this number will correspond to 0. So the minimum value is 0. And then the maximum is 255 because in 255, all the bits in that octet will be 1 1 1 1 1 1 1 1, 8 ones, right? So all 8 bits switched on, that is 255, and no bits switched on, so that is 0. So this 0 1 representation is the binary representation, and what we are seeing as minimum of 0 and maximum of 255 is the decimal number system or decimal conversion from the binary conversion. So why can an octet not exceed 255? Somebody might ask why the maximum value is 255, how it has been calculated. So basically, we have just seen that each octet in IPv4 address is 8 bits long. And in 8 bits, we have to see which all values we can put in to get the maximum value. So in this case, at each bit, it's 1. So we have 8 ones, right? So now, basically, to think of it in a different way is like each bit can have a value of 0 and 1, right? So this is 0 and 1, so this is 0 and 1. So it means there can be 2 bits at each position, 0 or 1. So now let's say if we have 2 bits and we want to see the maximum value, so it will be like 000110 and 11. So it means a 2 key power 2, right? So 4 is the maximum value we can have. So likewise, for 8 bits, if we set, so for 8 bits, we can have 2 key power 8. So 2 key power 8 comes a 256. Now, because we also have a 0, we can have 0 at each bit. So it means it will be like the maximum values will be 0 to 255. So that's why it cannot exceed 255, right? So basically 255 means all bits are switched on. How many bits and bytes is an IPv4 address? So as we have just seen, so total 8 bits in each octet. So eventually it's 32 bits in total. And if we divide it by 8, so it will be 4 bytes. So 32 bits or 4 bytes. IPv4 addresses, how many unique IPv4 addresses are possible? So in this our computer network series previously, when we were looking at IPv4 and IPv6 differences. So we found that basically IPv6 came because in today's world we have so many number of devices that to each device IPv4 address cannot be allocated because it has a certain limit. How many? So how many maximum IPv4 addresses can be given is based on the reasoning of that each bit can have 0 or 1, 2 values, and in total IPv4 we have 32 bits. So it means to keep our 32 uh, IPv4 addresses are possible, not more than that. So eventually we had seen previously that if we have more than 2 keep our 32 devices or 4.3 billion devices approximately, then we no longer have IPv4 addressing to provide to the new device. Okay. Then what is the loopback address? I think we haven't gone through yet about the loopback address, which we will be covering in the next part of this computer network series. But you can just remember for now that for IPv4 loopback address is 127.0.0.1, which is nothing but the device address. Okay. So if we are sending traffic or if we are sending data to this IP address 127.0.0.1, then it will never leave your machine or device. It will be just because this points to this local device address. So 127.0.0.1 is the loopback address. It always refers to your own device. Traffic sent to this address never leaves your machine. Smallest and largest possible IPv4 address. So smallest is 0000, where all the 8 bits, all the 32 bits are turned off, right? And largest can be wherein all bits, all 32 bits are set. So in that case, it's going to be 255.255.255.255. All 32 bits are switched on. And we remember from our previous uh, part of this computer network series. So 0000 is, and both 255, 255, 255, 255 are the special IP addresses, wherein 255.1 is the broadcast address and cannot be allocated to a device. Likewise, 0000 is having a different meaning. So in the case of IP address allocation, this address means nothing, right? So I think that is what it was, just a quick recap of what we had previously covered about IPv4 addressing basics. So I think we are good with basics, and we can looking at this question and answer, we can think of what we had covered earlier on this. I hope it was useful. Thank you.